In 1977, radio astronomer Jerry Ehman detected a mysterious radio signal while working on the SETI project. The signal lasted for 72 seconds and came from the constellation Sagittarius. It was so unusual and powerful that Ehman wrote "Wow" next to the reading. Despite numerous attempts, the signal has never been detected again, leaving scientists to wonder whether it was an alien transmission or some other unexplained cosmic event. The Great Attractor is a mysterious gravitational anomaly that seems to be pulling galaxies, including our Milky Way, toward it at an alarming speed of around 2.2 million kilometers per hour. Located about 150 million light-years away, it's incredibly difficult to study due to the dense galactic plane of the Milky Way. Its nature remains a cosmic enigma. Comprising about 85% of the universe's mass, dark matter is invisible to current detection methods and interacts with normal matter via gravity. Dark energy is an even more baffling force, responsible for the accelerated expansion of the universe. Despite their critical role in the cosmos, we still have no direct evidence of what these mysterious forces are. FRBs are powerful bursts of radio waves, typically lasting only a few milliseconds, that originate from distant galaxies. First detected in 2007, these intense bursts have been a mystery ever since. The origins of FRBs are unknown, with hypotheses ranging from the collapse of neutron stars to potential alien communication. Black holes are regions in space where gravity is so strong that nothing, not even light, can escape. At their core lies a singularity, a point of infinite density where the laws of physics break down. Despite their discovery decades ago, many aspects of black holes remain mysterious, especially the behavior of matter and space-time near the singularity. Ordinary matter, or baryonic matter, makes up only about 5% of the universe. However, astronomers have been unable to account for all the baryons predicted by the Big Bang theory. Some believe they may be hidden in warm gas in the intergalactic medium, but the puzzle remains unsolved. The cosmic microwave background, or CMB, is the afterglow of the Big Bang, and its uniformity has provided evidence for the standard model of cosmology. However, a region of the CMB, known as the cold spot, is significantly cooler than expected. Some researchers suggest it may be the result of a massive supervoid, while others speculate it could be evidence of a multiverse. Rogue planets are planetary bodies that don't orbit a star and instead drift freely through space. These planets may form in the same way as regular planets, but are ejected from their star systems. Hundreds of rogue planets have been discovered, but their origins and how they survive in the vast dark expanses of space remain a mystery. GRBs are the most powerful explosions in the universe, releasing more energy in a few seconds than the Sun will emit in its entire lifetime. While their exact origins are still debated, they are believed to be caused by supernovae, or the merging of neutron stars. What makes them especially mysterious is their immense energy, which could have potentially catastrophic effects if they occur too close to Earth. The Fermi paradox is the apparent contradiction between the high probability of extraterrestrial life in the vast universe and the complete lack of evidence for or contact with such civilizations. Despite the potential for millions of habitable planets in our galaxy, we have yet to find definitive signs of alien life, leaving the question of where is everybody unanswered. According to current physics, the Big Bang should have produced equal amounts of matter and antimatter. However, when matter meets antimatter, they annihilate each other, leaving behind energy. The fact that we live in a universe dominated by matter, not antimatter, is one of the greatest unsolved mysteries in physics. Why the imbalance occurred remains a perplexing question. The Hubble constant is a number that defines the rate at which the universe is expanding. However, measurements of this rate from different methods have led to a discrepancy known as the Hubble tension. Some methods suggest the universe is expanding faster than predicted by other observations, creating a cosmic contradiction that could point to new physics beyond the standard model. Fast radio bursts are incredibly energetic, millisecond-long bursts of radio waves that come from distant galaxies. Despite being discovered over a decade ago, we still don't fully understand their origins. Some scientists believe they could be caused by neutron stars, magnetars, or even aliens trying to communicate, but the true cause remains unknown. Cosmic strings are hypothetical, one-dimensional defects in space-time that might have formed during the early universe. They could be incredibly dense and thin, stretching across vast distances. Their existence remains unproven, but they are intriguing because they might explain some mysteries of the universe's formation and could potentially be detected through their gravitational effects. Known as the Great Void, the Bootes Void is a massive region of space with almost no galaxies or stars. It spans about 330 million light-years and is so empty that it's often referred to as the most isolated part of the observable universe. Why this void exists and how it fits into the larger cosmic structure remains an open question. Dark flow is the term used to describe the unexplained motion of galaxy clusters moving at extraordinary speeds across the universe, seemingly in the same direction. This motion cannot be explained by conventional cosmological theories, suggesting the presence of forces or structures beyond the observable universe, possibly hinting at the existence of other universes. The Oort cloud is a vast, icy region at the edge of the solar system, thought to be the source of long-period comets. However, we've never directly observed it. The mystery lies in how it formed and why its objects seem to remain in such a stable, distant orbit. It's also unclear why some comets from the Oort cloud are occasionally ejected into the inner solar system. In 2018, NASA's Curiosity rover found unusual, repeating geometric patterns in the Martian soil that resembled Turing patterns, a mathematical concept found in nature, like in animal skin patterns. The patterns, still unexplained, could be the result of a natural process or perhaps a sign of microbial life once existing on Mars. According to Big Bang nucleosynthesis, there should be much more lithium in the universe than we observe. Yet the amount of lithium measured in stars and galaxies is far less than predicted. This discrepancy, known as the lithium problem, could indicate gaps in our understanding of the early universe or new physics yet to be discovered. Quasars are incredibly bright and distant objects believed to be powered by supermassive black holes. They emit vast amounts of energy, but some quasars show unusual redshift patterns that defy conventional understanding. Some scientists hypothesize that these anomalies might suggest new cosmic phenomena, while others think it could be due to some unknown feature of space-time itself. Tabby's star, also known as Boyajian star, is a star that exhibits strange and unpredictable dimming patterns, unlike anything seen in other stars. Some theories suggest it could be due to alien megastructures, like a Dyson sphere, while others propose natural causes such as a cloud of comets. The bizarre nature of these fluctuations continues to puzzle astronomers. Dark matter is thought to make up about 27% of the universe's mass, yet we can't directly detect it. However, its presence can be inferred by its gravitational effects on visible matter. Researchers have been trying to understand the exact properties of dark matter and how it influences galaxy formation, but its true nature remains elusive. Could it be a new type of particle, or a more complex, unobservable phenomenon? The Antikythera mechanism is an ancient Greek analog computer that was used to predict astronomical positions and eclipses. Its complexity has baffled historians and scientists, suggesting that ancient civilizations may have had advanced astronomical knowledge. Some even speculate it could be evidence of lost technologies or contact with extraterrestrial intelligence. The Moon's formation is still a topic of intense debate. The leading theory is the giant impact hypothesis, where a Mars-sized body collided with Earth, creating debris that eventually coalesced into the Moon. However, questions about why the Moon's composition is so similar to Earth's mantle and how its orbit evolved remain unresolved. Some distant galaxies are glowing in an unusual way, emitting far more light than can be explained by known stellar activity. This unexpected brightness could be the result of previously unknown types of stars or energetic phenomena like active galactic nuclei, or it could point to exotic dark matter interactions. These glowing galaxies challenge our understanding of galaxy formation and evolution. Neutron stars are incredibly dense remnants of massive stars that have exploded in supernovae. They pack more mass than the Sun into a city-sized sphere. The matter inside a neutron star is so compressed that the usual laws of physics no longer seem to apply. Scientists are still working to understand the state of matter within these stars and how quantum mechanics and gravity work together in such extreme conditions. The accelerating expansion of the universe. Observations of distant galaxies show that the universe is not only expanding, but accelerating in its expansion. This surprising discovery was made in the late 1990s, and scientists attribute this acceleration to a mysterious force called dark energy. Despite dark energy accounting for about 70% of the universe's total energy density, its origin and exact nature remain some of the biggest unanswered questions in cosmology. The mysterious X-particles. Some experiments, particularly in particle physics, have hinted at the existence of particles that don't seem to fit within the standard model. These X-particles could be a manifestation of new physics, potentially providing insights into dark matter, dark energy, or other realms of space-time that are currently beyond our understanding. The origin of cosmic rays. Cosmic rays are high-energy particles that travel through space at nearly the speed of light. Though we know they are produced by powerful cosmic events such as supernovae and active galactic nuclei, their exact origins and the mechanisms by which they are accelerated remain a mystery. Cosmic rays carry immense energy, and their study could reveal much about the extreme conditions in the universe. The search for alien megastructures. As we look deeper into space, some scientists speculate that we might find evidence of advanced alien civilizations building megastructures like Dyson spheres, enormous constructs that would harness the energy of a star. In 2015, the Kepler Space Telescope detected a star, KIC 8462852, with unusual dimming patterns, leading some to consider the possibility of alien-built structures. While natural explanations exist, the possibility that we might one day find evidence of alien engineering remains an intriguing mystery. Quasars are the incredibly bright and energetic centers of distant galaxies powered by supermassive black holes. They emit vast amounts of energy, often outshining the rest of their host galaxy. However, their exact mechanisms remain mysterious. What drives the extreme energy output of quasars? Some theories suggest the presence of dense accretion disks, but many questions about their formation and behavior remain unresolved. Neutrinos are subatomic particles that interact only weakly with matter. They are produced in large quantities by stars and supernovae. However, some experiments have suggested that high-energy neutrinos appear to vanish as they travel through space. This phenomenon, known as neutrino oscillation, could point to unknown properties of neutrinos or possibly indicate a new type of physics beyond the standard model. The cosmic horizon marks the furthest distance from which light has had time to reach us since the Big Bang. Beyond this point, we can't observe anything, as the light hasn't had enough time to travel. The nature of this edge of the universe is still unknown, and some scientists suggest it might be a result of limitations in our current understanding of space-time and relativity. In 2018, astronomers discovered a galaxy made almost entirely of antimatter, specifically an antimatter version of hydrogen. Known as Hercules A, this discovery challenged many theories about the origins of galaxies and matter in the universe. How and why a galaxy made of antimatter could exist remains one of the greatest puzzles in modern astronomy. Astronomers have detected an unusual wobble in the orbit of Neptune, which could suggest the presence of an unknown large planet lurking beyond Pluto. This mysterious planet 9 is theorized to be about 10 times the mass of Earth, and is thought to be influencing the orbits of objects in the Kuiper Belt. Despite ongoing searches, it has yet to be directly observed. Supermassive black holes, found at the centers of most galaxies, are millions to billions of times more massive than our Sun. Despite their ubiquity, the formation of these monsters is still poorly understood. Did they form from smaller black holes merging over time, or are they the result of the collapse of massive gas clouds in the early universe? The exact process is still one of the great unsolved questions in astrophysics. Magnetars are a type of neutron star with an incredibly powerful magnetic field. These magnetic fields are so strong that they can twist and distort the fabric of space-time. Although magnetars were first discovered decades ago, their origin and how their magnetic fields get so intense remain a mystery. Theories suggest they could be the result of an extremely energetic collapse of a massive star, but much about their behavior is still unknown. 38. The Laniakea supercluster. The Laniakea supercluster is the vast cosmic structure that our Milky Way galaxy is part of. Stretching across 520 million light-years, it contains over 100,000 galaxies. Despite being mapped by astronomers, the motions of galaxies within the supercluster are still mysterious. The large-scale flows of galaxies within Laniakea point to the possible presence of unknown forces or unseen mass, beyond the influence of visible matter. 39. The enigmatic cosmic rays and their source. Cosmic rays are high-energy particles that travel across vast distances in space, reaching Earth from every direction. Despite decades of study, their precise origins remain elusive. While many are thought to be produced by supernova or active galactic nuclei, some cosmic rays have energies so high that current models of particle acceleration can't explain how they were formed. Could they be originating from even more exotic, unknown sources? 40. The puzzle of the galactic halo. The halo of our galaxy, the Milky Way, is a mysterious spherical region that surrounds the galaxy's visible disk. It contains faint stars, globular clusters, and, most intriguingly, dark matter. While dark matter is thought to be concentrated in the galactic halo, its exact distribution and structure remain poorly understood. New research on galactic halos is continually revealing new information about dark matter, but there is still much to discover. The mystery of the universe's missing antimatter. According to the Big Bang Theory, the universe should have created equal amounts of matter and antimatter. When matter and antimatter collide, they annihilate each other, producing energy. However, the universe seems to be overwhelmingly made of matter, and scientists still can't fully explain why there is such an imbalance between matter and antimatter. The enigmatic dark flow. Observations of galaxy clusters show that they are moving in a strange and unexplained direction. This mysterious motion, called the dark flow, suggests there could be large-scale structures or forces at play beyond the observable universe, possibly hinting at the existence of other universes or new unknown physical laws. The origin of cosmic inflation. The theory of cosmic inflation proposes that the universe expanded exponentially in the first moments after the Big Bang, but the exact cause of this rapid expansion remains a mystery. While the theory has been supported by observations like the cosmic microwave background, the physical mechanism behind inflation has yet to be explained. The missing 3 million light-years of universe expansion. When scientists measure the universe's expansion, they find an apparent discrepancy. Some regions of space seem to be expanding at rates that don't match predictions based on current models. This discrepancy is often referred to as the missing 3 million light-years and points to the possibility that there's some fundamental misunderstanding about the behavior of distant regions of space. Despite making up about 27% of the universe's mass, dark matter remains undetectable by current instruments. It doesn't emit, absorb or reflect light, making it invisible. Scientists are still hunting for dark matter particles and exploring theories that could explain its properties. Could it be made of weakly interacting massive particles? Or is it something more exotic entirely? The cosmic microwave background is the afterglow of the Big Bang, and it provides crucial evidence about the early universe. However, certain regions of the cosmic microwave background show strange temperature fluctuations that cannot be fully explained by existing models. One such anomaly is the cold spot, which suggests something might be interfering with our understanding of the universe's early history. Neutrinos are often referred to as ghost particles because they interact so weakly with matter. They are incredibly difficult to detect, but they are everywhere, produced by stars, supernovae, and even the sun. Their elusive nature makes them both fascinating and frustrating for scientists. We still don't fully understand their mass, how they oscillate between different types, or their role in the universe. The fastest known star in the universe, US 708, is traveling at a mind-boggling speed of over 1,000 kilometers per second, much faster than typical stars. Scientists speculate that this star could have been ejected from the supernova explosion of a companion star, or even formed during the collision of binary star systems. The true origin of this high-speed star remains uncertain. Hypernovae are extremely energetic supernovae that release far more energy than typical supernovae. They are believed to occur when a massive star collapses under its gravity, creating a black hole. However, the conditions that lead to the formation of hypernovae and their behavior in space remain a puzzle. Understanding them could provide key insights into stellar evolution and the fate of massive stars. Ultra-high-energy cosmic rays are particles with energies that far exceed anything we can produce in particle accelerators on Earth. These cosmic rays have been detected, but their origin is still a mystery. Some speculate they could come from supernova remnants, gamma-ray bursts, or even active galactic nuclei, but their exact source remains elusive. The Kuiper Belt is a vast region of space beyond Neptune that contains icy bodies, dwarf planets and comets. While most objects in this belt follow predictable orbits, some objects exhibit strange trajectories and behaviors that suggest the influence of an unseen force or planet. The mysterious Planet 9 hypothesis, a large unseen planet beyond Pluto, has been proposed to explain these unusual movements. The Great Attractor is a mysterious gravitational anomaly located in the direction of the Centaurus constellation. It seems to be pulling galaxies, including our Milky Way, toward it at a speed of millions of kilometers per hour. The source of this immense gravitational pull remains largely unknown, and the Great Attractor's true nature remains one of the most puzzling cosmic phenomena. Evidence suggests that Mars may have once harbored liquid water and possibly life. While no definitive proof of life has been found, ongoing missions like the Perseverance rover and previous discoveries, such as organic molecules and methane, have kept the question of life on Mars alive. What was Mars like in its ancient past, and could microbial life have once existed there? These remain tantalizing questions. The Fermi paradox asks why, given the vast number of potentially habitable planets in the galaxy, we haven't found any signs of extraterrestrial civilizations. This paradox remains one of the most perplexing questions in the search for alien life. Are advanced civilizations too far away? Do they self-destruct before becoming spacefaring, or are they deliberately avoiding contact? While scientists have a general understanding of how stars form from gas and dust, there are still many unknowns about the specifics of this process. For example, how do stars gather enough mass before they collapse into a supernova? What causes certain regions of interstellar clouds to collapse and trigger star formation, while others remain stable for billions of years? Fast radio bursts, or FRBs, are extremely powerful high-energy flashes of radio waves that last only milliseconds. Discovered in 2007, their exact origins are still a mystery. Theories range from the collapse of neutron stars or the merging of black holes to more speculative ideas like alien communication. The discovery of repeating FRBs has only added to the intrigue surrounding these cosmic phenomena. Giant squid are known to produce an enzyme called luciferase, which glows in the dark, but in space-time it's the fabric of the universe itself that is bending. The curvature of space-time, as predicted by Einstein's general theory of relativity, can cause light and other signals to follow warped paths around massive objects like black holes. Some astrophysicists speculate there are still properties of space-time yet to be uncovered. Could the connection between high-energy processes in deep space and complex biochemical phenomena provide new insights into the nature of the universe? The Boots Void is a vast region of space that is largely empty, devoid of galaxies. It stretches over 330 million light-years, making it one of the largest known voids in the universe. The void challenges current understanding of cosmic structure formation. Why is this region so barren compared to the dense clusters of galaxies elsewhere in the universe? Gamma-ray bursts, or GRBs, are the most powerful explosions in the universe, releasing vast amounts of energy in a short amount of time. They are believed to occur when a massive star collapses into a black hole, or when two neutron stars collide. However, the exact mechanisms behind GRBs remain elusive, and some scientists even suggest that they could be used as probes to study the most extreme conditions in the universe. The Cosmic Dark Ages refers to the period after the Big Bang, when the universe was filled with neutral hydrogen gas and no stars had yet formed. This era is mysterious because it was followed by the formation of the first stars, marking the beginning of the Rhionization period. What triggered the formation of the first stars and galaxies, and how did the universe transition from a dark, neutral state to the bright, star-filled universe we see today? Dark energy is a mysterious force believed to make up about 70% of the universe, driving its accelerated expansion. Despite being a fundamental part of modern cosmology, its true nature remains completely unknown. Dark energy doesn't emit light or any form of detectable radiation, so scientists are struggling to find ways to study it directly and understand how it interacts with space-time. Blue straggler stars are stars that seem to be much younger than their neighbors in the same star cluster. They are unexpectedly bright and hot, suggesting they formed more recently, but their age doesn't match the other stars around them. This phenomenon is a major puzzle, and some theories suggest these stars may have been rejuvenated by interacting with other stars or by merging with a companion. Dragonfly 44 is a galaxy that defies expectations because it appears to contain almost no visible matter, yet its gravitational pull suggests it has the mass of a large galaxy. This mysterious galaxy has led astronomers to speculate that dark matter could play an even more significant role in galaxy formation than previously thought. According to simulations, there should be many more small satellite galaxies orbiting larger galaxies like the Milky Way. However, astronomers have found far fewer than expected. This missing satellites problem suggests that either our current models of galaxy formation are incomplete, or there may be something preventing small galaxies from forming or surviving. Pluto and Neptune share a strange orbital relationship. While their orbits bring them close to each other, they never collide. This is because their orbits are in a resonance, with Pluto's orbit taking it far enough from Neptune's path, avoiding any collision. The precise mechanics behind this stable and seemingly improbable orbital dance is still an intriguing puzzle for astronomers. The intriguing alien megastructure around Tabby's star. Tabby's star, also known as KIC 8462852, has had its brightness inexplicably fluctuate, with some dimming events lasting for extended periods. While natural explanations like dust clouds or comets have been proposed, some have speculated that this irregular dimming could be caused by an alien megastructure, like a Dyson sphere, designed to harvest energy from the star. The mystery of Tabby's star continues to captivate astronomers. The giant cosmic lenses. Gravitational lensing occurs when a massive object, like a galaxy or black hole, distorts light from objects behind it, acting like a giant cosmic magnifying glass. While it has been used to discover distant galaxies and map dark matter, the exact distribution of these cosmic lenses and their role in the universe's larger structure is still being explored. Are there lenses that reveal hidden or even distant universes? The strange light from neutron star mergers. When two neutron stars collide, they produce a burst of energy so powerful it can be detected across great distances. The 2017 detection of the merger of two neutron stars in the GW 170817 event provided important clues about these cosmic collisions. But the exact mechanism behind the unique light that was emitted in the event, called a kilonova, is still not fully understood. The puzzle of planetary migration. The theory of planetary migration suggests that planets in a star system can move from their original positions due to interactions with the gas and dust in their protoplanetary disks. While this theory has been supported by observations in our own solar system and in distant exoplanet systems, the exact processes and causes of planetary migration, as well as its impact on a planet's habitability, remain mysterious. The origin of the solar system's water. Water is abundant on Earth, but its origin is still debated. Some theories suggest it came from comets or asteroids that impacted Earth early in its history, while others propose that it may have formed from chemical reactions within the planet itself. The true origins of Earth's water, and how it became so abundant, continue to puzzle scientists, especially as they consider whether other planets or moons in our solar system might have similar sources of water. The strange behavior of rogue planets. Rogue planets are planets that do not orbit a star and instead wander freely through space. Some scientists believe that these planets could have formed around a star and then were ejected into interstellar space due to gravitational interactions, while others hypothesize that they could form in isolation. The very existence of rogue planets raises questions about the dynamics of planet formation and whether these planets could support life. The mystery of the galactic supermassive black hole. Most large galaxies, including the Milky Way, contain a supermassive black hole at their center. However, the exact process by which these enormous black holes form and grow is still unclear. Do they start out as smaller black holes that accumulate matter over time, or do they form from the collapse of a massive star? Understanding their growth could provide new insights into galaxy formation. The puzzle of cosmic voids. Cosmic voids are vast expanses of space where very few galaxies exist. These voids can span hundreds of millions of light years and make up about 80% of the universe's volume. What causes these voids to form, and why are they so large? The nature of voids challenges current models of galaxy formation and may provide clues about dark energy or the large-scale structure of the universe. The unusual nature of blazar galaxies. A blazar is a type of active galactic nucleus that contains a supermassive black hole with a relativistic jet pointing directly toward Earth. Blazars are incredibly energetic, emitting powerful radiation across the electromagnetic spectrum, but their exact behavior and the nature of their jets remain mysterious. How are these jets formed and what powers them? The study of blazars could provide vital clues about the physics of supermassive black holes. The astounding nature of quark-gluon plasma. Quark-gluon plasma is a state of matter that existed just moments after the Big Bang. In this state, quarks and gluons, the building blocks of protons and neutrons, are no longer confined within particles but move freely through space. Recreating and studying quark-gluon plasma in particle accelerators has given scientists a deeper understanding of the early universe, but many questions remain about how this strange form of matter behaves and its role in the formation of galaxies and stars. The search for the first stars, also known as Population 3 stars. Population 3 stars are believed to be the first generation of stars to form in the universe, composed almost entirely of hydrogen and helium. These stars would have been much larger and hotter than those that formed later, but they are incredibly difficult to detect. Studying Population 3 stars could provide insights into the formation of the first galaxies and the chemical enrichment of the universe. Many young stars are surrounded by powerful winds that are made up of charged particles. These winds, known as X-winds, can be observed coming from stellar nurseries, but how they form and why they seem to be so intense in certain regions is still not fully understood. Could these winds play a role in the formation of planets or the distribution of matter in star-forming regions? The galactic halo surrounding galaxies like the Milky Way is believed to be made up of dark matter, an invisible substance that does not emit light. While we know it exists based on gravitational effects, the exact distribution and properties of dark matter within the halo remain a major mystery. How do galaxies form and grow in the presence of dark matter, and could this help us understand the true nature of dark matter? Fast X-rays are bursts of high-energy radiation that last only a few milliseconds and are often associated with violent cosmic events like black hole mergers or neutron-star collisions. The exact mechanisms behind these short bursts of X-rays remain a mystery. Could they be linked to previously unknown processes in the formation of supermassive black holes? Or could they be the result of new particle interactions? A white hole is the theoretical opposite of a black hole. While black holes suck in everything that crosses their event horizon, a white hole is thought to expel matter and energy, making it essentially a reverse black hole. While no white holes have been discovered, some scientists believe they could explain some mysterious cosmic phenomena such as high-energy cosmic jets, or even be connected to wormholes. Oumuamua is an object from outside our solar system that passed through our cosmic neighborhood in 2017. Its unusual shape, acceleration and rapid speed defied expectations for a typical asteroid or comet. Some theories even suggest that it could be an artificial object, though most scientists believe it's a natural phenomenon. The true nature of Oumuamua remains a subject of intense debate, sparking speculation about alien technology, solar sail structures and more. cosmic reionization refers to the period when the first stars and galaxies formed and began to emit radiation, causing the neutral hydrogen in the early universe to become ionized. While we know that this process must have occurred, the exact timeline and the sources of this ionizing radiation are still unclear. Understanding this period is key to understanding the formation of the first galaxies and the evolution of the universe. The cosmic web is the large-scale structure of the universe, consisting of vast voids and intricate filaments of dark matter and galaxies. The exact processes that shape the cosmic web are still not fully understood. How did these filaments and voids form, and what role does dark matter play in this structure? The cosmic web is central to understanding how the universe evolved from a hot, uniform state to the complex structure we see today. The Earth's magnetic field is generated by the motion of molten iron in the outer core. However, recent studies suggest that the magnetic field might be undergoing significant changes, with some researchers proposing that it could be preparing for a magnetic pole reversal. What causes these changes, and how will they affect Earth and its life forms? Could similar magnetic fields exist elsewhere in the universe? The enigma of supermassive stars. Supermassive stars are incredibly massive, potentially hundreds of times the mass of the Sun. Their formation and eventual collapse into black holes remain a mystery. How can stars become so massive, and what happens to them during their life cycles? Are they truly the precursors to supermassive black holes, or do they follow different evolutionary paths than smaller stars? The dark flow of galaxy clusters. The phenomenon of dark flow refers to the apparent movement of galaxy clusters in a specific direction as though being pulled by an unseen force. This motion cannot be explained by the gravitational effects of visible matter and suggests the presence of an unknown force or even an external influence from outside our observable universe. This mysterious dark flow raises fundamental questions about the structure and dynamics of the cosmos. The Hubble tension problem. There is an ongoing tension in measurements of the universe's expansion rate, known as the Hubble constant. Different methods of measuring the rate of expansion give conflicting results. This discrepancy challenges our understanding of the universe's age, its future, and the nature of dark energy. Is there an unknown factor at play, or is there something wrong with our measurements? The mystery of the high-energy X-rays from black holes. Black holes are known to emit X-rays, especially when they pull in matter from a companion star. However, some black holes are producing unexpectedly high-energy X-rays, far more than models can explain. What processes occur near the event horizon of these black holes that could lead to such extreme radiation? Are we missing something about how black holes generate energy in their accretion disks? The role of magnetospheres in planetary atmospheres. The magnetosphere is the region around a planet dominated by its magnetic field. For Earth, this protects us from harmful solar radiation. However, scientists are still investigating how magnetospheres influence the long-term evolution of planetary atmospheres. Can a strong magnetosphere be crucial for maintaining habitability? And could the study of magnetospheres in other star systems offer insights into potential life on exoplanets? The unseen edge of the universe. The edge of the universe is a philosophical and scientific enigma. While the observable universe is finite and extends 46 billion light-years from Earth, what lies beyond that observable limit? Is the universe truly infinite, or does it have some kind of boundary? Furthermore, how do we even define the edge when space itself is constantly expanding? The mystery of the zombie stars. Zombie stars are a term used to describe stars that have undergone unusual transformations, such as the phenomenon of a star being revived after it should have died. In some cases, a dead star, like a white dwarf, can be re-energized by material from a companion star, causing it to flare up again as though it were a living star. Understanding how this revival occurs and the long-term effects it has on stellar evolution is still a mystery. The true origin of cosmic rays. Cosmic rays are high-energy particles that originate from outside the solar system. They are constantly bombarding Earth, and while we have a general understanding that some come from supernova, others are much more energetic and harder to trace. Some of the most powerful cosmic rays could originate from distant galaxies, black holes, or even the earliest moments of the universe, but their precise origin is still unknown. The search for intergalactic life. Most efforts in the search for extraterrestrial life focus on nearby planets, but life beyond our galaxy remains a largely unexplored mystery. Could there be life forms thriving in other galaxies far beyond the Milky Way, in environments entirely different from Earth? How would we even begin to search for such life in the vast expanse of intergalactic space? 94. The puzzle of the galactic rotation curve. When astronomers measure the rotation curves of galaxies, they find that stars on the outer edges of galaxies move much faster than expected. This discrepancy suggests that there is unseen mass, dark matter, in the galactic halo that is influencing the star's motion. While dark matter is widely accepted as the solution, its exact nature and distribution in galaxies remain mysterious. 95. The curious case of the Great Filter. The Great Filter is a concept that tries to explain why we have yet to find intelligent extraterrestrial life, despite the vast number of stars and planets in the universe. The theory suggests that there might be a catastrophic barrier or series of steps that life has to overcome, and most civilizations never make it past this filter. Whether the Great Filter is behind us or ahead of us is one of the most intriguing existential questions. 96. The unsolved nature of the universe's expansion. While the universe's expansion is well established, the exact cause of this expansion, especially the acceleration, is still unclear. Dark energy is thought to be responsible, but no one knows exactly what dark energy is or why it causes the universe to expand at an ever-increasing rate. Could the fundamental laws of physics need to be rewritten to account for this accelerated expansion? The mystery of the solar anomaly. A solar anomaly refers to unusual unexplained behavior of the Sun, such as sudden increases in solar radiation, sunspot cycles that don't follow expected patterns, or unexpected bursts of solar wind. While solar activity is well understood in many respects, these anomalies challenge our models of the Sun's behavior, and their causes are still being investigated. The peculiar ring of fire of exoplanets. Many exoplanets have been discovered in a region of space known as the habitable zone, the area around a star where liquid water could exist. But some exoplanets also exhibit strange behaviors like unusual volcanic activity, massive magnetic fields, or unexpected atmospheric composition. Could these planets, with their wild features, harbor life forms radically different from anything we know? The elusive cosmic rays and their connection to black holes. Cosmic rays are extremely high-energy particles that travel through space, but some scientists believe they may be linked to the behavior of black holes. These rays could be produced by high-energy processes in the vicinity of black holes, such as the accretion of matter. However, the exact mechanism for how these particles are accelerated to such high speeds by black holes is still not fully understood. The quest to understand time's direction. Time flows in one direction from past to future. This arrow of time is a fundamental aspect of our experience, but why does time only move forward rather than backward? The laws of physics themselves are symmetrical, meaning they don't necessarily dictate a preferred direction for time. Understanding the nature of time's one-way progression could reveal deep insights into the very structure of the universe. The cold spot is a large, unusually cold region in the cosmic microwave background radiation, which is the afterglow of the Big Bang. This cold region is much colder than the surrounding areas, and its cause is still unclear. Some hypotheses suggest that it could be the result of a collision with another universe, while others point to unknown cosmic processes. The cold spot could hold answers to deep questions about the early universe. Cosmic inflation is the theory that the universe expanded exponentially during the first moments after the Big Bang. This expansion helped explain the uniformity of the universe. But the details are still unclear. What caused inflation? Was it a natural consequence of the laws of physics, or is there something more fundamental driving this rapid expansion? Solving this could revolutionize our understanding of the universe's origins. Some exoplanets exist in environments so extreme that they defy our typical understanding of what constitutes a habitable world. Planets orbiting extremely close to their stars, or planets with violent volcanic activity, may still harbor life, but in ways radically different from life on Earth. How would life adapt to such extreme conditions? The search for life on these unusual exoplanets could expand the definition of habitability. Gamma-ray bursts are the most energetic explosions in the universe, releasing as much energy in a few seconds as the sun will over its entire lifespan. While we understand that they are often caused by supernovae or neutron star mergers, the exact mechanism behind these intense bursts is still unclear. What causes them to release such massive amounts of energy in such short bursts? And can they have significant impacts on life in other parts of the universe? The Oort cloud is a distant region of icy bodies that surrounds the solar system, but little is known about it because it lies far beyond Pluto. Scientists hypothesize that comets that enter the inner solar system may come from this region. However, no direct observations of the Oort cloud have been made, and its exact structure, size, and composition remain unknown. Understanding the Oort cloud could provide crucial clues about the early solar system. Quasi-periodic oscillations, or QPOs, are rapid variations in the X-rays emitted by matter falling into black holes. These oscillations appear to follow a specific frequency, but remain irregular in their pattern. The cause of these QPOs remains unknown, though some theories suggest they could be linked to the behavior of material in the accretion disk around black holes. Their study could reveal critical details about the nature of black holes and the extreme environments surrounding them. According to the Big Bang nucleosynthesis theory, the universe should have produced a specific amount of lithium during its early moments. However, the amount of lithium observed in the universe today is much lower than predicted. This missing lithium problem has puzzled astronomers for decades. Is there some unknown process that destroyed lithium over time, or is the theory itself flawed? The Magellanic Stream is a vast gas-rich structure that stretches for thousands of light-years across the sky. It is thought to be composed of material torn from the Large and Small Magellanic Clouds, two of the Milky Way's satellite galaxies. While the stream's existence is well documented, the forces that created it and the long-term impact it will have on the Magellanic Clouds and the Milky Way remain unclear. Gravitational lensing occurs when a massive object, like a galaxy or black hole, bends light from objects behind it, magnifying and distorting the light. While we understand the basic principles behind gravitational lensing, there are still strange instances where light from distant galaxies behaves in unexpected ways, such as forming unusual arcs or producing multiple images. What could be causing these odd lensing effects? And what new insights could they offer into the structure of the universe? Dark energy is thought to be responsible for the accelerating expansion of the universe, yet its nature remains completely unknown. One of the greatest mysteries is why the effects of dark energy have become more pronounced only in the most recent epoch of the universe's history. What caused dark energy to dominate the expansion rate of the universe after the Big Bang, and how will its effects evolve in the future? The Moon's rotation is synchronized with its orbit around Earth, a phenomenon known as tidal locking. As a result, one side of the Moon always faces Earth. While we understand the general process behind tidal locking, the exact dynamics of how it happened and why other moons in the solar system do not always exhibit perfect tidal locking are still under investigation. The Sun's corona, the outer atmosphere of the Sun, is inexplicably much hotter than the Sun's surface. Scientists have detected strange whispers or oscillations in the corona that could provide clues to this phenomenon. Understanding these oscillations might help us understand the complex magnetic interactions and energy transfer occurring within the Sun, which could have broader implications for solar weather and its impact on Earth. Hypergiant stars are some of the most massive stars in the universe, but their behavior remains puzzling. They are much larger and hotter than regular stars like the Sun, and they are often unstable, exhibiting massive fluctuations in brightness. These stars are rare and short-lived, but they play a key role in stellar evolution and the creation of heavy elements. Understanding their life cycles could shed light on the fate of extreme stars. The Sun's variability over long timescales, such as sunspot cycles and solar flares, has been well documented. However, the exact mechanisms driving the Sun's long-term changes are still unclear. These variations can influence the solar wind and cosmic radiation, impacting the Earth's climate. How do these long-term changes fit into the Sun's overall life cycle, and what do they tell us about other stars? Rogue planets are planets that do not orbit a star, but instead drift through interstellar space. It's unclear how these planets form and what happens to them over time. Some scientists hypothesize that they could have been ejected from their home systems, while others think that rogue planets could form in the depths of space, independently of stars. Their existence challenges our understanding of planetary formation and stability. Fast blue optical transients are rare, extremely bright explosions that occur in the optical spectrum. These events are much faster than typical supernovae, sometimes reaching peak brightness within just a few days. Their origin remains uncertain, though some scientists believe they may be linked to the collapse of massive stars or interactions with a black hole. The exact cause of their sudden, intense emissions is still a puzzle. Pulsating white dwarfs are stars that exhibit periodic brightness fluctuations caused by oscillations in their outer layers. While we understand the basic physics behind these pulsations, some white dwarfs exhibit unusual pulsation patterns that are hard to explain. These irregularities could provide valuable insight into the internal structure of white dwarfs and the physics of dense matter. Supermassive black holes are found at the centers of most large galaxies, including our own Milky Way. But how do these black holes form? The traditional view is that they grow from the collapse of massive gas clouds, but the formation process of such massive black holes in the early universe is still unclear. Were they seeded by smaller black holes that merged, or did they form through a completely different mechanism? The gamma-ray sky is full of high-energy radiation that originates from various cosmic sources like active galactic nuclei, pulsars, and supernova. While much of this radiation can be traced back to these known sources, there are still unexplained gamma-ray bursts in regions of space where no obvious source can be identified. What produces these mysterious bursts of gamma radiation, and what can they tell us about extreme processes in the universe? The Great Extinction refers to the notion that there might have been periods in the universe's history when life as we know it was wiped out across vast regions of space. Some theories suggest that cosmic events, such as supernovae, gamma-ray bursts, or the explosion of hypernovae, could have caused massive extinctions by exposing Earth and other planets to dangerous radiation. Is there a recurring cycle of cosmic extinction events? And what does it mean for the future of life? Rogue stars are stars that wander through the galaxy without being bound to any particular star system. Some are thought to have been ejected from their original locations due to gravitational interactions, while others may have formed in isolation. The existence of rogue stars challenges our understanding of stellar formation and dynamics, especially regarding their influence on the interstellar medium and galactic evolution. The Oort cloud is a theoretical spherical shell of icy bodies at the outermost edge of the solar system, and it is believed to be the origin of long-period comets. However, the precise mechanics of how comets are ejected from the Oort cloud and how their orbits are influenced by galactic forces remains unclear. Do interactions with passing stars or the gravitational forces of the Milky Way's disk play a role in shaping these orbits? The Planet 9 hypothesis suggests that there could be a ninth, yet-to-be-discovered planet in the outer reaches of the solar system. This planet is theorized to be about 10 times the mass of Earth and to have an orbit far beyond that of Neptune. While no direct evidence of this planet has been found, the unusual orbits of distant trans-Neptunian objects have led some scientists to believe that Planet 9 might exist. How would such a massive object affect the solar system? And will we ever confirm its presence? Dark lightning is a mysterious phenomenon that occurs within thunderclouds, producing bursts of gamma rays without the visible light of traditional lightning. Unlike regular lightning, which emits visible light and heat, dark lightning releases energy in the form of gamma radiation. Scientists are still unsure why this form of lightning exists, what triggers it, and how it might influence atmospheric chemistry and the global climate. Uranus has a magnetic field that is tilted by about 60 degrees from its rotational axis, which is highly unusual compared to other planets in the solar system. This oddity has baffled scientists because magnetic fields are generally expected to be aligned with the rotation of the planet. What causes this strange orientation? Is it related to the planet's unique formation, or is there an internal mechanism at work that we don't yet understand? Zombie stars are a rare phenomenon where a star, after going through a supernova explosion, appears to reignite in some form, becoming a new type of stellar object. These stars are believed to be remnants of binary systems where one star undergoes a supernova and the material from the explosion causes the companion star to revive in an unexpected way. The process behind the revival of these zombie stars and their ultimate fate remains a topic of intense study. X-class solar flares are the most powerful type of solar flare, capable of emitting vast amounts of X-rays and ultraviolet radiation. These flares can disrupt communications, GPS systems, and even power grids on Earth. Despite their power, the specific mechanisms behind how these flares form and why they occur in bursts are not yet fully understood, and the exact impact they might have on Earth's climate and technology is still a mystery. Antimatter is a type of matter composed of antiparticles that are the opposite of normal matter. When antimatter meets normal matter, they annihilate each other, releasing enormous amounts of energy. The universe seems to be made almost entirely of normal matter, but the question remains, why is there so much more matter than antimatter in the observable universe? The creation and asymmetry between matter and antimatter remains one of the greatest unresolved mysteries in physics. Cosmic voids are vast, empty regions of space that are largely devoid of galaxies and other matter. These voids can span hundreds of millions of light years and represent some of the largest structures in the universe. Their formation is still not fully understood. Are they the result of gravitational collapse, or do they arise from the expansion of the universe itself? The nature of these voids and their role in cosmic evolution is still a subject of ongoing research. Starburst galaxies are galaxies that are forming new stars at an exceptionally high rate, often tens to hundreds of times faster than typical galaxies. These galaxies often emit massive amounts of ultraviolet radiation and can be seen as extreme examples of stellar birth. However, why some galaxies experience such intense star formation, while others do not, remains an unresolved question in galaxy evolution. The Big Rip is a hypothetical scenario in which the accelerated expansion of the universe caused by dark energy eventually becomes so intense that it tears apart galaxies, stars, planets, and even atoms. While this remains a speculative theory, if dark energy continues to accelerate the universe's expansion, this scenario could lead to a catastrophic end to the cosmos. The timeline for such an event, if it were to occur, is still uncertain, but it remains one of the more dramatic potential futures for the universe. Magnetars are a rare type of neutron star with an extremely strong magnetic field, trillions of times stronger than Earth's. These stars can emit intense bursts of X-rays and gamma rays, and their magnetic fields can warp space-time around them. The exact cause of such powerful magnetic fields in magnetars and how these stars evolve over time remains a mystery in astrophysics. Their unique properties are still not fully understood. Accretion disks are rotating disks of gas and dust that spiral around black holes, eventually being pulled in by the black hole's immense gravity. The turbulence within these disks can cause fluctuations in the radiation emitted, but the details of how these turbulent dynamics work remain unclear. How material behaves in the intense gravitational fields near black holes could provide crucial insights into both the black hole's structure and the nature of space-time itself. The idea of alien megastructures is one of the more speculative yet fascinating concepts in the search for extraterrestrial intelligence. This hypothesis suggests that advanced civilizations might build large-scale structures such as Dyson spheres harnessing the energy of a star, or large-scale space habitats that are detectable by their energy emissions. While no direct evidence has been found, certain star systems like Tabby's star have shown unusual dimming behavior that some suggest could be the result of such megastructures. Neutron star mergers are violent cosmic events where two neutron stars collide, producing gravitational waves and heavy elements like gold. While we have detected these mergers through gravitational waves, thanks to observatories like LIGO, the details of the merger process, how the neutron stars spiral toward each other, and what happens in the final moments of collision remain mysterious. These mergers also hold clues to the behavior of matter under extreme conditions, potentially allowing us to probe the interior of neutron stars. The Fermi paradox asks why, given the vast number of potentially habitable planets in the universe, we have not yet encountered any signs of extraterrestrial civilizations. If intelligent life is common, why is there no clear evidence of it? The paradox has led to numerous theories, ranging from the idea that civilizations are too far apart in time and space, to the possibility that advanced civilizations self-destruct or intentionally avoid contact with us. The search for extraterrestrial life continues to be one of the most intriguing mysteries in science. Baryon acoustic oscillations, or BAOs, refer to the periodic density fluctuations in the early universe caused by sound waves propagating through the hot plasma that filled the universe in its infancy. These oscillations left a distinct imprint on the distribution of galaxies and can be used as a cosmic ruler to measure the expansion of the universe. While BAOs provide valuable insights, the exact relationship between these oscillations and the overall structure of the universe is still being investigated. The Great Attractor is a massive gravitational anomaly located in the Laniakea supercluster, which is pulling our Milky Way galaxy, along with many others, toward it at an incredible speed. The exact nature of the Great Attractor is still unknown, as it is obscured by the dense region of the Milky Way's plane. Is it a supermassive black hole, a cluster of galaxies, or something even more exotic? The mystery of the Great Attractor continues to challenge astronomers. In some cases, astronomers have observed supernovae occurring in pairs or groups at roughly the same time. This simultaneous occurrence of star explosions is puzzling because we would expect these events to be scattered randomly across the universe due to their nature. Are these supernovae triggered by a larger cosmic event or intergalactic interactions? Or is there some unknown force causing them to appear together? Cosmic rays are high-energy particles, primarily protons, that travel through space at nearly the speed of light. While some cosmic rays are believed to come from the Sun, others are thought to originate from distant galaxies or supernovae. The source and acceleration mechanism of the most energetic cosmic rays are still unclear, and these particles can have significant impacts on space exploration, human health, and even Earth's atmosphere. Hot Jupiters are gas giant exoplanets that orbit extremely close to their parent stars, much closer than Jupiter is to the Sun. These planets are puzzling because they are much hotter than other planets in the solar system due to their proximity to their stars. The question arises, how do these massive planets end up in such close orbits? Some theories suggest they may have migrated inward from farther regions of the star system, but the exact mechanisms behind this migration are still not well understood. Fast radio bursts, or FRBs, are brief, intense bursts of radio waves that last only a few milliseconds, but release immense amounts of energy. These bursts are believed to come from distant galaxies, but their exact origin remains one of the biggest mysteries in astrophysics. Some hypotheses suggest that FRBs could be linked to the collapse of neutron stars, interactions with black holes, or even alien technology. So far, no definitive explanation has emerged. Solar wind is a continuous stream of charged particles emitted by the Sun, and it interacts with the Earth's magnetosphere to produce phenomena like auroras. However, the detailed processes of how the solar wind interacts with Earth's magnetic field and how variations in the solar wind can influence space weather events like geomagnetic storms are still not fully understood. Understanding this interaction is crucial for protecting satellite communications and power grids. Mars has a magnetic anomaly in the form of large, localized magnetic fields scattered across its surface. These magnetic regions suggest that Mars once had a global magnetic field, much like Earth's, which is currently absent. What caused Mars's magnetic field to disappear, and how did this impact the planet's habitability? Understanding this anomaly could provide crucial clues about Mars's past and its potential to support life. Neptune has a series of moons that have perplexed scientists, particularly Triton, which is unique in that it orbits Neptune in the opposite direction of the planet's rotation, a retrograde orbit. This suggests that Triton may have been captured by Neptune's gravity, rather than forming in place. The origin of Triton and other irregular moons around Neptune is still unclear, and their study could provide valuable insights into the formation and evolution of outer solar system objects. Giant galaxies are some of the largest structures in the universe, containing enormous amounts of stars, gas, and dark matter. However, astronomers are puzzled by how these galaxies formed and why they are so large compared to typical galaxies. A key mystery is the relationship between their stellar mass and the dark matter that surrounds them. Do giant galaxies have an unusually high concentration of dark matter, or do they follow the same dark matter distribution as smaller galaxies? In addition to dark matter, which accounts for most of the gravitational effects observed in galaxies, scientists suspect there could be other forms of unseen matter in the universe, such as dark baryons or exotic particles. These might not interact with light, but could still exert gravitational influence. The search for these unknown forms of matter continues to be a major area of astrophysical research. Lithium was one of the elements created during the Big Bang in a process known as Big Bang nucleosynthesis. However, the amount of lithium found in the universe today is much lower than what models predict. This lithium problem raises questions about the accuracy of our understanding of the early universe and the processes that created the light elements. Is there a missing piece to our model, or is some process depleting lithium over time? The cosmic microwave background radiation, CMBR, is the faint afterglow of the Big Bang, and its uniformity has been a key piece of evidence for the Big Bang theory. However, recent observations have revealed strange anomalies in the CMBR, such as a cold spot and slight temperature fluctuations that don't perfectly align with theoretical models. What could be causing these anomalies? Are they signs of new physics, or could they be the result of something more profound like the multiverse? The faint young sun paradox refers to the apparent contradiction between the sun's early weaker energy output and the fact that Earth seems to have been warm enough for liquid water to exist, even in its early history. If the sun was only about 70% as bright as it is today, how could the Earth have remained warm enough to support life billions of years ago? This paradox is still unsolved and continues to puzzle scientists exploring Earth's early climate. Gamma-ray bursts, or GRBs, are among the most powerful and energetic events in the universe. These bursts release as much energy in a few seconds as the sun will over its entire lifetime. While some GRBs are thought to come from the collapse of massive stars, others seem to originate from the merging of neutron stars or other exotic events. The mystery remains about what exactly triggers these bursts in such extreme ways, and how we might detect and study their origins. Venus has a unique rotational characteristic. It rotates on its axis very slowly and in the opposite direction to most other planets in the solar system, known as retrograde rotation. Venus also has a day that is longer than its year, taking about 243 Earth days to complete a single rotation. Scientists are still uncertain as to why Venus has such a peculiar rotational period, and whether it is related to its dense atmosphere or a past event, such as a massive collision. Several theories exist about how the universe might eventually come to an end, from the Big Freeze, where the universe keeps expanding and cooling, to the Big Crunch, where the universe contracts back on itself, to the Big Rip, where the accelerating expansion tears everything apart. Which of these scenarios will occur, and will any of them be influenced by the mysterious properties of dark energy? The eventual fate of the universe remains a profound question for cosmologists. The concept of the edge of the universe is a difficult one, as the universe is thought to be expanding. The observable universe is limited by the speed of light and the time since the Big Bang. Beyond the observable universe, we cannot currently see or detect anything, but some theories suggest that the universe may extend infinitely, or that there could be other universes beyond our own. What, if anything, lies beyond the observable universe, and can we ever access it? When black holes merge, they release enormous amounts of energy in the form of gravitational waves, which are ripples in space-time detected by observatories like LIGO. However, there's still much to learn about the amount of energy involved in these mergers, especially for extremely massive black holes. How does the energy released during these mergers compare to the total energy contained within the black holes themselves? How do these mergers influence the surrounding space and even the formation of galaxies? The Great Cold Spot is an unexplained anomaly in the cosmic microwave background radiation that represents a large, unusually cold region in space. This cold spot appears to be larger than expected, and its exact cause is a subject of intense debate. Some theories suggest it could be the result of a collision with another universe, a remnant from the Big Bang, or simply an unknown cosmic structure. Understanding this cold spot could reveal crucial information about the early universe and its formation. Galactic cannibalism occurs when one galaxy absorbs another through gravitational interactions. This process can result in the merging of galaxies, leading to the formation of larger galaxies. While it is believed to be a common occurrence in the universe, the full extent of how galaxies consume each other and the long-term consequences of such mergers are not well understood. How do these cannibalistic events shape the evolution of galaxies, and can they explain certain peculiar galaxy structures? Uranus and Neptune have magnetic fields that are tilted and off-center, unlike the magnetic fields of Earth and other planets. The cause of these unusual magnetic fields is not well understood, and theories suggest that it might be related to the planet's internal structures or the presence of a highly conductive liquid interior. What is the underlying cause of these magnetic anomalies, and how do they impact the dynamics of the outer solar system? In 2011, an experiment at the Opera laboratory in Italy suggested that neutrinos, subatomic particles, might be able to travel faster than the speed of light, which would challenge Einstein's theory of relativity. While the initial findings were later attributed to a measurement error, the idea of faster-than-light particles has sparked ongoing debate. Could there be a way to bypass the universal speed limit? And what would this mean for our understanding of physics? Black holes have such immense gravitational fields that they warp space-time around them. However, understanding exactly how this warping works, particularly near the event horizon, the boundary beyond which nothing can escape, remains a significant mystery. The extreme conditions near a black hole lead to paradoxes, such as the information paradox, where information about matter falling into a black hole seems to be lost forever. Can quantum mechanics resolve these paradoxes, and is it possible to see inside a black hole? Dark energy is the mysterious force that is causing the accelerated expansion of the universe. While it accounts for about 70% of the universe's energy content, very little is known about its properties or origin. Some theories suggest that dark energy is a form of vacuum energy, or that it could be a manifestation of a new fundamental force. How does dark energy influence the future of the universe, and could understanding it unlock new aspects of physics? Hawking radiation is a theoretical prediction by physicist Stephen Hawking, which suggests that black holes can emit radiation and slowly lose mass over time, eventually evaporating completely. While the idea has profound implications for our understanding of black holes, it has yet to be observed directly. How can we detect this radiation, and what would the eventual evaporation of a black hole mean for the information that it contains? Monstrous stars are stars that are far more massive than theoretical models predict. The existence of stars up to 100 times the mass of the Sun challenges our understanding of star formation, as the current models suggest that such massive stars should be unstable and unable to form. What forces allow these supermassive stars to exist, and what is their ultimate fate? Quantum entanglement is a phenomenon in quantum physics, where particles become intertwined in such a way that the state of one particle instantaneously influences the state of the other, no matter how far apart they are. This phenomenon has been demonstrated on small scales, but it raises questions about the role of quantum entanglement in the cosmos. Could entanglement play a role in the behavior of black holes or the structure of the universe itself? The question of what occurred at the edge of time, or at the moment of the Big Bang, remains one of the deepest mysteries in cosmology. What happened during the Planck time, the first tiny fraction of a second after the Big Bang, when both space and time were incomprehensibly small? Was there a cause for the Big Bang, or did the universe come into existence without cause? And can we ever understand the very beginning of time itself? Dark matter is a mysterious form of matter that doesn't emit light or energy, making it undetectable by conventional means. Yet its presence is inferred from its gravitational effects on visible matter such as galaxies. What exactly is dark matter, and how does it shape the formation and evolution of the universe? Could it be composed of exotic particles that we have yet to discover? Or could it represent an entirely new type of physics beyond our current understanding? The multiverse theory proposes that our universe is just one of many in a vast multiverse, each with its own set of physical laws and constants. While intriguing, the theory raises significant challenges, particularly with the concept of falsifiability. How could we ever test whether other universes exist, and if they do, how might they interact with or influence our own universe? What does the multiverse theory imply for the uniqueness of our existence? The Great Filter is a concept in the search for extraterrestrial life that suggests there is some incredibly rare event or process that prevents most civilizations from reaching advanced stages. It could occur at any point in the development of life, from the origin of life itself to the technological prowess required to survive the challenges of space. Could we be the only civilization in the galaxy to have passed this filter? Or is the universe full of intelligent life that simply hasn't survived long enough to make contact? The theory of everything, or TOE, is a hypothetical framework that would unify all fundamental forces of nature, gravity, electromagnetism, weak nuclear force, and strong nuclear force into a single theoretical model. String theory and quantum loop gravity are among the leading candidates for TOE. How could a unified field theory change our understanding of the universe? What might it reveal about the fundamental nature of reality, and what new physics could it uncover? The simulation hypothesis posits that our reality is an artificial simulation created by a more advanced civilization. Proponents argue that technological advancements might one day allow for the creation of simulations indistinguishable from actual reality. Could we be living in a simulated universe? What would it mean for our concept of free will, consciousness, and the nature of reality itself if we were to confirm that our existence is a simulation? The Fermi paradox addresses the apparent contradiction between the high probability of extraterrestrial civilizations existing and the lack of any detectable evidence or communication from them. Why have we not yet encountered alien life despite the vastness of the universe? Are advanced civilizations simply too far away? Or is there something about the nature of intelligent life that prevents long-term survival and communication across interstellar distances? The anthropic principle suggests that the universe appears to be finely tuned to support life, with the physical constants and conditions in place seemingly perfect for the emergence of life as we know it. This raises the question, is this a result of sheer cosmic luck, or is there some deeper reason for this fine-tuning? Does the existence of intelligent life imply that the universe is designed with life in mind, or is it a product of a random, multiverse-like scenario? The arrow of time refers to the one-way direction of time from the past to the future. In physics, time seems to flow in one direction. But why is this the case? What underlies the asymmetry of time, and how does the concept of entropy, which states that disorder tends to increase over time, explain the arrow of time? Could there be a fundamental cause for the progression of time, or is it merely a result of the laws of thermodynamics and the evolution of the universe? Dark energy is a mysterious force that is driving the accelerated expansion of the universe. Although it accounts for approximately 68% of the universe's total energy content, its properties remain largely unknown. What exactly is dark energy, and how does it influence the fate of the universe? Could it eventually cause the universe to expand forever, or will it lead to some unforeseen catastrophic event like the Big Rip? The ultimate fate of the universe remains uncertain, and several hypotheses propose different scenarios. Will the universe continue expanding forever, cooling and becoming more inhospitable? Or will it eventually contract in a big crunch? Alternatively, could the universe experience a dramatic end via the Big Rip or other unknown mechanisms? What will the end of the universe look like, and will any form of life, intelligence or consciousness survive to witness it?